if something is not clear, or you want me to repeat something like that, by all means, just throw something into the chat, and we'll and I'll try to monitor that as best I can. So let me share screen here. All right. Hopefully, oh no, like this. Wrong screen. When I share screen, maybe somebody could tell me, do you see the full PowerPoint screen, or are you seeing like the kind of presenter mode? It's not giving me a little green box around, so I can't tell.
I can see the full screen here, Dan.
Full screen. Okay, great. All right, so let's get started. So yes, today's lecture, this would be aimed at a first year course. I took an existing lecture for our Environmental Science 201 class, which is a first year introductory class, and I modified it a little bit and shortened it for the purposes of today, and we've called it Water, Water Everywhere. So we'll start with a poem, or part of a poem. Water, water everywhere, and all the boards did shrink. Water, water everywhere, nor any drop to drink. And so this is from a poem called The Rime of the Ancient Mariner, and it relates the experience of a sailor who's returned from a long voyage at sea. Sailing around Antarctica, the continent of Antarctica, the ship gets lost, and an albatross, which is sort of like a gigantic seagull, leads them to safety out of the pack ice. The mariner shoots the albatross, and the ship then becomes cursed. And the ship eventually makes its way to the equator, where it becomes marooned, just sort of floating on the sea. There's no wind. This is basically due to what are called the doldrums, which you might remember from a week or two ago when we were talking about wind patterns. Anyway, the sailor gets very thirsty, and even though the sailor is surrounded by water floating on the open ocean, of course it's all salt water, and they can't drink any of it to slake their thirst. So what does that poem have to do with environmental science? Well, it's I would say, pretty commonly held belief that Canada is blessed with a essentially endless supply of fresh water. But is that really true? You may have heard that Canada has something like 20% of the world's fresh water, but not all of that is available for use in an easily readable way. Canada's lakes and rivers hold something like 7% of the world's total renewable freshwater. And the rest of it is deep underground or in glaciers, essentially locked up, frozen. And so not really available for human use. And so, yes, we do have a lot of water on the surface, but when you drill down deeper a little bit, we're surrounded by all this water, sort of, but not all of it is available for use. So we're, a little bit like the sailors surrounded by the ocean, but can't actually slake their thirst because they can't drink any of it. So how much fresh water does Canada actually have? Well, roughly 20% of Canada's landmass is covered by fresh water. So we're not talking about the oceans here, just lakes and rivers and reservoirs. Something like almost 2/3 of Canada's freshwater actually drains to the north, or is in the north, and so not readily available for most of Canada's population. And that's because 85% of Canada's population lives within about 300 kilometers of the US border, the southern border, not the Alaskan border. And so most of our fresh water is not actually where the people are. So how much do you think you use on a daily basis? So maybe we can, if you're happy to, you can throw into the chat what your guess is of how much you use on a daily basis. I'll give you a minute or two to do that. Don't be shy. Maybe I should tell you what units we should use. Yeah, let's go with Michael's units here, and let's use liters. Okay, so Michael says 100 liters, 20 liters, 120 liters. Any other guesses? maybe one more minute here. 200 liters. So Canada and Canadians are amongst the world's sort of thirstiest people. So I don't mean just that how much water we drink, but how much water we use on a daily basis. So according to the federal government, total per capita is basically just a fancy way of saying per person. Total per capita water use averaged 401 liters per day per person per day in 2021. This was actually a decrease of about 11% since 2015. And so this is not just for drinking. Total per capita water use here includes industrial, residential, commercial, and some other water uses provided by public utilities. So like the city of Calgary, for example. If you get your water from a well, you wouldn't be counted in these statistics. So those of you that guessed, between 100 and 200 liters, that's still a lot of water, but that's a half to a quarter of what we actually, every person in the country is actually using on a daily basis, if not just thinking about how much you're drinking and the water you put in your pasta water or flush the toilet, etc. Now, you can see every province is a little bit different here. Each of these colors refers to a different year, but in general, every province and territory, water use has for the most part, been decreasing over time up to 2021 and presumably up to the present as well. Now, it's hard to compare these numbers with those from other countries because everybody measures things differently or includes different things. And so on this next world map, you'll see a bunch of countries are grayed out because we don't have great data for them. But as you can see here, the pattern is that, Canada and the US and a couple of other countries in Asia are pretty dark red. Canadians are amongst the world's heaviest users of water on a per capita basis. The average American uses something like 1,500 cubic meters per year. The average Canadian uses about 1,100 cubic meters per year. So these units are cubic meters, not liters, but which is what the 401 that I mentioned before. 1,100 cubic meters per year works out to something like 3,000 liters per day. And one of the big differences between this number here, 3,000 liters per day, and 400 liters per day from the prior slide, is that this includes agriculture, as well as some other uses that were not counted in that previous one. So regardless of the specific number, you can see that we're pretty thirsty people here in Canada. We use a lot of water. So surface water, so things like lakes and rivers, reservoirs, supply almost all of the water we use in Canada, at least as of the last time this was collated for the whole country. Nearly all of that is treated by some municipalities. So like the water that we drink here in Calgary, for example, we get from the Bow and the Elbow rivers, and this is treated by the city of Calgary. Only about 1% of Canadians use untreated water, and I'm pretty sure this means this refers to people who get their water from the well. So you might have read in the news or seen on TV or heard on the radio, here in Alberta, especially the southern part of Alberta, we're in a drought, a pretty serious one. We're currently in stage 4 of 5 levels. That's this sort of press release here that you can see on the upper left of the screen from the Alberta government. So a level 4 out of 5 drought basically means that there are multiple water management areas. So think of those as different regions of the province experiencing large scale water shortages. If we get to stage 5 out of 5, that would be a declaration of an emergency under the Water Act. So, what we're at right now is pretty serious, even though, the water still flows when you turn on the tap and, walk along the Bow River, there's still water in it. But as you've probably seen on the news or heard about, there's been a lot written. These are just from the last few weeks about what this might mean for, for us in different parts of the province, especially here in southern Alberta. We may have watering restrictions as soon as May 1st. Not too far away now. Now, please don't try to read all this. Fortunately, the government provides these data just in a table format, whereas some other jurisdictions, I'll show you in the next slide, make these interactive maps and websites that are much more user-friendly. But anyway, what we've got here is the amount of water in each of our reservoirs. In other words, behind the various dams that we have all over the province. And what I want you to look at is what's inside this rectangle here, which is the proportion of the total possible storage for each reservoir that's currently filled with water. So in other words, how full each one is. So the Paddle River Reservoir, which is fairly small, is about half full as of a week or two ago. The South Heart Reservoir, which is also not that big, but nevertheless, it's about 3/4 full. You can see that the reservoirs in the south of the province, so these sort of, the Bow River watershed and the Oldman River watershed, these ones are not doing quite as well. They're much less full than those in the north in general. Some, like the Oldman and the St. Mary, are dangerously low. So you can see the St. Mary Reservoir here is only at 17% of its capacity. But it's not a massive reservoir. The Oldman Reservoir, which is one of the biggest in the province, is only at 1/3 of capacity. So really not a lot of water in these reservoirs. Now, I mentioned a minute ago that some other jurisdictions, other states and countries and provinces, whatever, provide these kinds of data in a kind of a graphical interface, which is a little bit easier to look at. So this is an example from California, which is probably the best that I've seen. This is the water dashboard for, or the reservoir dashboard for California. So this is a screen grab from late summer 2014, and then this is just, I grabbed this morning. Basically, each of these bars shows the total capacity for each reservoir. The red lines on the left-hand side, green lines on the right-hand side, they just changed the way the dashboard looks a little bit. The red lines represent how full, on average, the reservoir was on that particular date that the dashboard is showing. So on August 29, the long-term average. And then the blue is how full it is on that actual date. So not only the average of all August 29th, but August 29th, 2014. And the general story here is that, a decade ago in California, the reservoirs were really empty. You might have seen photographs of a lot of their reservoirs, which normally people are boating on, and sometimes as houseboats, that sort of thing. And all the boats were sitting on the lake bottom, basically. Fast forward to now in California. California is probably now out of their very severe multi-year drought. And you can see that almost every reservoir is substantially above the long-term average for that date. Now, the differences that you look at here, not only have they changed the color of things, they've changed where the reservoirs are placed. So like here, Trinity Lake is on the upper left, Shasta Lake is on the upper left here. So, you need to kind of look around a little bit, but you might see, like, for Lake Shasta, it's about 3,000. Here is the capacity, the historic average. And here it's closer to 4,000, maybe 3,700, 3,800. The reason for that is because this is the average for the end of summer after, it's been dry, lots of people using water to water the lawns, that sort of thing. Whereas this is at the end of winter when, we're starting to get a lot of snow melt, that kind of thing. So that's why these green lines are, the green and the red lines are a little bit different. Anyway, all that to say, some jurisdictions have really nice dashboards for this sort of thing. But here we've got, the information is still more or less the same, but we've got a table to look at. All right, so back to Alberta. So on the top is a satellite image from a California company called Planet Labs. And we're showing here the Oldman Reservoir. This image, the upper one is from April 3rd of 2024, so just a few days ago. And the bottom one is from March of 2021. So you can think of this bottom one as being more or less typical conditions for the Oldman at the end of winter, beginning of spring. And here is what it looks like right now, a couple of days ago. You hopefully can see just how different, especially sort of in these shallower parts of the reservoir. It's basically bone dry here, but here it's full of water. Any of these little arms here, this southern arm is basically dry, whereas a couple of years ago it was pretty full. So in other words, the reservoir, we can look at the numbers, but I think it's much more striking when we look at a photograph, in this case, a photograph from space. Here's another one, your St. Mary Reservoir. On the left is from mid-March 2024, so about a month ago. And then here, this is from March 2021 again. So you can see just how drastically different they are. All this brown area, this is dry. Basically, the white is, frozen lake water. And here, the sort of bluish white is a reservoir full of water with a little bit of ice on the top. So a lot less water in most of our reservoirs right now. So why are Alberta's reservoirs so dry? Well, there's a variety of factors, one of which is lower than average precipitation for the last several years. So in other words, less rain, less snow on average. Another one is lower than average summer flow in the rivers in this past summer, 2023. So in other words, all of that precipitation, the snowfall, the rain, makes its way to the rivers transport it into lakes and reservoirs. And so if you have less water in the rivers, then you're going to have less refilling of the reservoirs. And then just this past winter, very low snowpack in the mountains. For those of you that are snowshoers and skiers, you might have noticed just how bare the mountains were for almost the whole winter. We did have couple of pretty colossal storms over the last few weeks, and that's definitely helping. But for most of the winter, things were really dry. And so due to the combination of these reasons, we are in a state of drought right now, and things look pretty bad for this summer. Now, Alberta's a little funny when it comes to water. We use an allocation system referred to as first in time, first in right. And this system uses so-called priority as the determining factor in certain water-specific situations. So priority in this context is the date, basically the date that a water allocation, a water license was recorded in the system. So, when you apply for a water license, they put the date and the time on it, and that date and time tells you your place in line. And so under the laws and regulations that we have in Alberta, there's no priority given to any specific use. So agriculture isn't necessarily above oil and gas or municipal uses like drinking water, et cetera. It's all about when that license was issued. In southern Alberta, 100% of water is allocated already. So in other words, there are no more licenses available to be given out. So if we want to build a new municipality, you might have heard about 10,000 new houses in Canmore coming, or a new subdivision in Calgary, that sort of thing. There's no more water to give out. So in other words, somebody has to sell a license, transfer a license to a new user. What's shown in this map, or these couple of maps here, is how much of the available water is spoken for in terms of already allocated. The general story here is in the north of the province, these lighter kind of whites and grays, you can see here, not much of the water is spoken for because there's not a lot of water users up here. In the south, it's a very different story. So keep in mind, this map here is from 2010. And so, we've had nearly 1.5 decades since this map was updated. So, you can think of all of these colors kind of shifting to the blues and the pinks a little bit over the last decade and a half. So, we've got many of the water regions, the watersheds in southern Alberta. Oh, there's a question in the chat there. Were these reservoirs impacted from the changes in water systems from the flood we saw? Do you mean the 2013 floods? Sorry, that was a question back to you, Michael. And then curious about the underground system. Do we have systems to tap into those to help their loss? Now, Michael, do you mean by underground systems, you mean aquifers, in other words, water that's stored underground, or are you talking like pipes in the cities? Maybe while you're typing, I'll mention briefly about the natural storage. So the reservoirs impacted by the floods. It's a good question. I don't know the answer to that. I did not live here at the time. Typically, when we know that a really big storm is coming, and in the case of 2013, that was a very intense storm, but on top of a very thick snowpack. And so you get what's called rain on snow, and you can think of it, when you have thick snowpack that has a lot of water in it, and then you add rain to it. Rain is relatively warm. It's going to melt all that snow and liberate all that water that's in the snow and flow downstream. That's why those floods were so big. And so typically when we know we're going to have a really big storm, the dam operators will let out a bunch of water to make room behind the dam to store more water as it comes in. I don't know in terms of dams that were damaged necessarily, but I do know that there have been some dam construction projects to mitigate future floods, going forward. Is it the Bearspaw Reservoir? I'm forgetting the name of it now, but there's one kind of upstream from Calgary that's being built as a flood diversion project. In terms of your question about underground sort of natural water storage, so what we call aquifers, yes, I mean anybody who has a well is like a water well is pulling water from an aquifer. In general, in Calgary, we don't use aquifer water. We use essentially all of our water comes from the Bow and the Elbow rivers. Now, some of the flow in those rivers is coming from groundwater, but the vast majority is coming from snow melt and glacier melt and the lakes upstream, further up in the Rockies. I'm not sure about Edmonton. I suspect they get most of their water from the North Saskatchewan. Okay, where was I? So what maybe put into the chat some water users that you can think of. I don't mean like, your neighbor Jim, but rather categories of water users that you can think of. So municipal drinking water, would be one category. What other categories do you think there could be? Agriculture, great. Yeah, we have a lot of agriculture here, especially, the kind of agriculture here we have, we have a lot of beef cattle and those consume an awful lot of water. So absolutely, Kyla, or Kyla's iPad anyway. Any other water user categories that anyone can think of? Industrial, yeah, great. So industrial could be a whole variety of things, especially here in Alberta, could be oil and gas. Healthcare, yeah. So healthcare would probably be classified under municipal, I think. And same thing with flushing toilets. That would be all a municipal in the municipal category. So there's one other, so we've listed most of the categories here. There's one other category, which is called other. And that's basically recreation. So water to have in the rivers for rafting, kayaking, water in the reservoirs for people to go boating, that sort of thing, but also for fish and wildlife. We have Westlope, cutthroat trout, that kind of thing in our rivers that require a certain amount of water at certain times of the year. And so dams or the operators of the dams need to let out appropriate volumes of water to sustain the fisheries that are in those rivers. So here's a pie chart. Apologies for the kind of dated appearance of it, but it's from 2010. It's the latest one I could find from the government. So we can see here each of the slices of pie here represent the amount of water by different sectors. So green, purple, yellow, pinkish, and purple, and and this kind of, I don't know, mauve or whatever, as of 2010. So this is, the annual total for the entire province split up. So you can see agriculture is nearly half of the total water usage in the province. Commercial is, maybe about a quarter. Industrial is a relatively small fraction, I don't know, 20% or something like that. And industrial here would include oil and gas. And then, this municipal here. So this is, the cities of Calgary, Edmonton, Red Deer, Spruce Grove, etc. And then these kind of pinkish ones here, these are this other category. So fish and recreation, etc. So do you think the graph would look different if we looked at individual watersheds or different regions of the province? How do you think if we were to look up these same data for the Athabasca River watershed? Do you think that would look really different from the South Saskatchewan where we, the Bow River watershed, basically where we live? How might those be different? What categories do you think would be really different in those? Less agriculture, Kyla's iPad, less ag in which? In Athabasca or Bow River? Yeah, Athabasca, probably. What do you think would be more in Athabasca? Yeah, absolutely. So industrial. So this yellow category here in the Athabasca watershed, oil and gas, occupies a massive piece of this pie. Now, keep in mind, everywhere it always has to add up to 100% for that region. It just depends on how it's split up between all these different users. So, for the first time in nearly a quarter century, the province has embarked on negotiations to come up with some water sharing agreements for the Red Deer, the Bow, and the Oldman River basins. This was sparked by this drought that we've been talking a little bit about. Now, this is, as you can maybe guess, based on what I've said already, this is an incredibly tricky negotiation. It's really, really tough stuff because the water license holders really they hold 100% of the power. In essence, the biggest water license holders are being encouraged to voluntarily share more water with municipalities and industry primarily, as there's no law that can force them to share. So in other words, the whoever got their licenses first, they, because they feel maybe it's the right thing to do or whatever, they can voluntarily share more water with people in the city of Calgary or in Blairmore or whatever, but they don't actually have to. And so the original deadline for these negotiations passed a few weeks ago, but the government extended that to mid-April. And they've scheduled a press conference for April 19th to explain what the agreement will look like. And so, if you care about water, and I hope that, everybody on this call actually cares about water because, we need it to live, then I would suggest stay tuned and read the news, on April 20th to see how the water landscape, if you will, in the province may change this year. So let's go back to Samuel Coleridge's poem here, the Rime of the Ancient Mariner. And this was not about water quantity exactly, but really about water quality. So let's change tack a little bit and let's talk about water quality for a few minutes. So some of you or some of your parents probably had heard of the Walkerton disaster. So that's this middle screen grab from CBC here, where Walkerton is a city in Ontario, town in Ontario, and E. coli got into the drinking water supply, and that resulted in 7 deaths, and nearly half of the population of the town fell ill, like really sick. The town has a population of about 5,000, something like 2,500 people got sick. Ultimately, this was due to poor water quality monitoring protocols. Maybe instead you've heard of Flint, Michigan. So the story on the upper left here. And so the city wanted to save money, as all cities do. They were looking to save about $5 million over 2 years. And so this industrial town near Detroit cut its ties with the Detroit Water and Sewerage organization, basically that produces or that takes wastewater and gives clean water. And instead, they hooked up their municipal water supply to the Flint River. They did this in April of 2014. The switch was meant to be temporary until they could transition to a new regional water authority. In other words, like a new organization that would provide clean water. For the 50 years before that, Flint had pumped water in from Lake Huron, one of the Great Lakes, which was treated through the Detroit system. Water sourced from the Flint River, though, this was the new river that they were getting water from, is more corrosive than the Lake Huron water. And so because this Flint River water was not treated, the Flint water pumped through the municipal system basically began to eat away and corrode the pipes. And that resulted in lead being leached out of these pipes and getting into tap water. And so residents quickly began complaining about the cloudiness. And you can see it here, it's disgusting. Cloudiness, the color, the taste, the smell of this new tap water. Some of them started developing rashes and losing hair. They started getting headaches, all sorts of other problems. They blamed the drinking water for these health effects. Within 4 months of this changeover, some tests of the local water samples detected fecal coliform bacteria, as well as pretty alarming levels of a potentially harmful chemical compound, which is a byproduct of chlorine. Between 6 and 12,000 people, 6 and 12,000 children were exposed to drinking waters with levels of lead that were unhealthy. The water supply change was also the cause of an outbreak of a disease called Legionnaire's disease that killed 12 people. Michael asks, historically, how long do these droughts last in our province? Tricky question with the changes in our climates, but curious if you know timeframes as far as historic data supports. If we believe this to be a problem for the following decade and 50 years from now, are there any discussions on how to supplement our supply? Great question, Michael. So over the last couple of decades, I believe most of the droughts that we've had have lasted kind of 3 to 4 years. Drought's a tricky thing to talk about because drought does not just mean there's no rain. The drought can come from a whole variety of factors. It can come from no rain, no snow. It can come from the soil just being too dry. So there might be lots of water, but if that water is not making it onto the fields, for example, to irrigate the corn and the wheat, then that's an agricultural drought, and it's not necessarily due to not enough water, but not enough water in the rivers or in the pipes, but not enough water in the soil. We can have an issue of just too many people. So maybe the water, or too many users, I should say. Maybe the amounts of rainfall are not, changing, but we've grown by 1 million people, let's say, in the province, and now there are just too many people for the amount of water storage that we've got. The second part of your question is about how do we adapt to this? If this is going to be a bigger issue going forward, think about, all our iconic glaciers in the Rockies, in 50 years, many of those will be gone or not, not very large at all. And so those are ultimately supplying a lot of the water that we get in our rivers. What is that going to do? What is our drought landscape going to look like in 50 years? It's a great question. I don't know what the provinces and cities are doing to plan for this long term. This is a very expensive proposition. No doubt there are people working on it, but I don't know what those conversations look like. I think it would be very interesting to be a fly on the wall for those sorts of discussions. Okay, so this is an article here from the Star, from Toronto Star from 4 or 5 years ago. This was a result of a year-long investigation by something like 120 journalists across the country. They collected test results in 11 cities across Canada. And of 12,000 tests done since 2014, 33% exceeded the national safety guidelines of 5 parts per billion of lead. So these are just directly from the article. City of Edmonton, they had 630 failed tests out of however many they had, which was essentially a 30% failure rate. So 30% of the tests done in Edmonton failed these lead level guidelines. In Moose Jaw, there were fewer failed tests, but there were fewer houses in Moose Jaw. 73% of the tests failed. Saskatoon, even more drastic. 85% of the tests failed. Toronto, 2%. So, when I saw this number, I was pretty surprised. I figured, well, Toronto's a pretty old city, probably lots of old lead pipes all over the place. I was expecting this to be very, very high. So historically, Toronto's lead levels were amongst the highest in Canada, with as many as half the tests exceeding the provincial lead standards, at least the 2008 lead standards. Shortly after that, the city began adding some chemicals to the water, which reduced the corrosion in the pipes. So basically, they did what Flint, Michigan did not. And today, as a result of those chemicals being added to reduce corrosion, less than 2% of the tests fail in Toronto. So, those of us that live in Calgary, you're probably all wondering, well, how did Calgary do? So unfortunately, the Star article did not have the stats for Calgary. However, story in the CBC also from 2019 found that, yes, actually, there are a whole bunch of homes in Calgary that are connected to lead pipes. And so this is, pipes that could be within somebody's home, but more, or maybe not more often, but an equally large issue is pipes, the pipes that connect, out in the street or in your alley, that supply water from the city that then connect into your house. The junction between those pipes is often lead. So we're going to wrap up here in a few minutes. One of the really serious water quality issue that doesn't really receive very much press in Canada is water quality on First Nations reserves. So many reserves across the country have had boil water advisories for years, some for decades. So there are literally, university age kids in reserves across the country that have had boil water advisories their entire lives. And so the Liberal government, when they were first elected, they promised to end all of the so-called long-term drinking water advisories on reserves by March of 2021. And so remember, the Trudeau government came into power in November of 2015. And at the time, there were 105 long-term drinking water advisories on reserves. Long-term here means for 1 year or more. And during the Liberals' first term, nearly 100 advisories were lifted. That sounds pretty good. But over 36 new ones were imposed. And so, they came into power in 2015. They wanted to basically finish this in 2021. But what happened in 2020, COVID no doubt played some role in the pace of action here, not being quite what was promised. However, as of 2024, this is, I grabbed these data just the other day, but they were last updated a couple of months ago. 144 long-term drinking water advisories have been lifted and only 28 remain. On the right here, this is a map of all the locations in red, these red, what would these be, hexagons, showing the places where the advisories are still in effect. And these are almost all in Northern Ontario and Manitoba. So a lot of success here, but still a lot of work left to do. Okay, Kyla says, is water quality monitored at source or throughout the distribution system? So at source, Kyla's iPad, I'm assuming you mean at the water treatment plant where the water begins its journey to your home. So not at the source, like in Bow Lake, for example, which is the source of the Bow River. So if that's what if you mean, yes, monitored, as far as I know anyway, monitored at the water treatment plant, but once it leaves the water treatment plant, goes into the city's pipes, is no longer monitored. In our environmental science 401 class, which is a field course that we do largely in Kananaskis, for the last couple of years, we've taken a tour of their water treatment plant there, which is a pretty new facility. I think the previous one was destroyed, or not destroyed, but damaged in the 2013 floods there. And anyway, we get a tour of their very fancy lab and see kind of the types of tests they do to look at water quality. It's pretty neat stuff. Smelly, but pretty neat. And then Michael says, are there systems that would change the electrical charge of the water to reduce corrosion? I have absolutely no idea. But you know what? I'm going to take a note and I'm going to get back to you next class. Okay, so I mentioned at the beginning, we know Canada has something like 20% of the world's fresh water, but only 7% of the renewable freshwater, available freshwater. And so first we should really define that term. So renewable resource is one that is replaced, or in other words, replenished naturally over time. Okay, so what does that actually mean? So what does over time mean? Does that mean millions of years? Geological time? Typically what we mean with the term renewable resources is that it's replenished over human timescales. So in other words, decades, years to decades. Some components of the water cycle have really long residence times. And by residence time, I mean the time that a molecule of water spends in any given spot. So in a lake, in a river, in a glacier, in an aquifer, etc. Some of those can be thousands and thousands of years. On top of that, as a global average, less than 3% or so of all the water is freshwater, and most of that is frozen in snow, lake ice, glaciers, or is deep underground. So there's actually very little fresh water that's available for use on the planet. The vast, vast majority of it is in the oceans. So the total amount of water on Earth is essentially fixed. It's not affected by human activities. To be useful to humans, though, it must be in a particular place, at a particular time, at a particular quality, etc. And these factors that you see here, these all affect where water goes, when it goes there, etc. In addition to these factors affecting the quality and the quantity of water, there are factors affecting the amount that gets used or that is sort of that we want to use. Population growth, which is not directly mentioned here, population growth is a big one. So by 2050, the UN estimates that there'll be something like 10 billion people on the planet. Most of them will be in countries that are already water starved. So in other words, where water is already a finite and very valuable resource, where there's not enough of it. Climate change is also not explicitly mentioned here, but in very simple terms, as we increase air temperature, we increase the amount of evaporation from lakes and reservoirs, we increase the amount of evapotranspiration from plants, etc., and we change precipitation patterns. So is water a renewable resource? I'd say yes, but it's complicated. As with many things in the environmental sciences, as you'll discover over your 4-year degree, there are very few things that are black and white. Most things are different shades of gray. And with that, I'm going to leave you the last slide here. This is a time series of water consumption in Edmonton during the Olympic gold medal hockey game in 2010. And you can read this graph and figure out what it means. And with that, I'm done.
Awesome. Thank you so much. That was very informative. I definitely learned quite a bit about, water use and definitely lots of things that I didn't know already. So I'm just going to share my screen really quickly here, and we're just going to go through a presentation. So because most of you are going to be prospective students, this is just talking a little bit about your journey to the University of Calgary. So if you really enjoyed this lecture today and it's inspired you to become a UCalgary Dino, this is going to help you on that path. So first we have here is just a little bit about the university in general. So we were founded in 1966. We're not even 100 years old yet, and we already have about 28,000 undergraduate students, 5 campuses, 14 faculties. We're Canada's entrepreneurial university, and we have about $504 million in sponsored research funding. These are some of my favorite statistics right down here at the bottom. So the 94% after graduation employment rate, and then the 95% undergraduate retention rate. That's saying that 95% of students who come to us for their first year will stay with us for their entire degree. So it kind of speaks to student life satisfaction and all that kind of stuff. And then this is just a little bit about our admissions information. So just our general requirements, all of our programs, your admission is competitive and it's going to be based on 5 faculty specific classes. So your average that we're looking at is just going to be based on 5 classes that's specific from program to program. And then some of the programs that have additional requirements, so that might be a supplemental writing piece or an audition or portfolio, would be the Bachelor of Health Sciences, as well as Fine Arts, Dance and Music for the audition, and then Fine Arts Visual Studies for the portfolio. And then as well, all students must demonstrate English language proficiency. So that's ELP. And if you have any questions about that, please don't hesitate to put them in the chat. I'll be answering them after if you have any. This is just a couple of pieces about the admissions information for the Bachelor of Science in Environmental Science. So these are those 5 faculty-specific classes that I was kind of talking about. So we've got English, Alberta Mathematics 30-1 or equivalent, 2 of these sciences here, so biology, calculus, chemistry, or physics, an approved course or option. Those are typically your more fun classes. So the ones that you're taking, whether that be gym, foods, drama, dance, anything like that. And then the average that we're looking for is going to be in the low 80s. So that's going to be an overall average of those 5 classes. We're looking at being in the low 80s. So that's just for our environmental science program. And then these are just some important dates that we have for the upcoming admission cycle. So 2024, 2025, these ones are for fall 2025 admissions. So the one date that's missing on the slide here is we do have international admissions opening on August 1st for fall 2025. And then for domestic students, it's going to be opening on October 1st. So this is a really great slide to kind of keep in mind. It shows all the dates that you're going to be looking at throughout your entire admission cycle with us, right from the start all the way to the end. And then if you're looking to connect with us here, you can scan these QR codes on the screen, or you can also follow us on any of the social medias here on the right side of the screen. So again, you know, I kind of oversee the different social medias that we have. So we've got the Instagram, the Facebook, our email up there. We do have a Pinterest account, and then we also have a podcast. And then afterwards, after this lecture today, it will be posted on our YouTube channel. So it's just going to be Choose You Calgary. So if you want to go back and rewatch it, you totally can. It's a great opportunity to kind of go back and see if you missed a part or anything like that. And then that's all that I have for you guys today. Nice and sweet for you. If you have any questions for Dan, please feel free to put them in the chat. And then I'm going to answer any questions when it comes to admissions, just off screen here. So.
Okay, question about basically desalination. Michael, that's a great question. None that I know of, but you know, I certainly don't know of everybody, all the different professors' research projects across the university. You know, there very well may be somebody in chemical engineering doing that kind of thing. But you know, I know that there are there is existing tech to do that kind of thing, but I don't know if there are specifically if there are research projects ongoing right now at the university looking at that. Estefania asks, what are some other parameters for monitoring water quality that are taken into account aside from lead levels? So, you know, one of the things that we do, I mentioned that the environmental science 401 field school that we do in Kananaskis, and during that course, we actually do a fair bit of water quality measurements we do that, or at least typically from year to year, we do that here in the Elbow River, as well as up in Kananaskis, in the Kananaskis River. Excuse me. And when we look at the Elbow River, for example, one of the things that we're interested in is looking at E. coli. And so, you know, if you live in Calgary, you may have seen the news, you know, oftentimes in the summer, like in July, we'll get news reports about how we shouldn't be, you know, going to recreate in the Elbow, you know, don't go swim. Well, there's typically not enough water to swim in the Elbow, but, you know, shouldn't go splashing around in the Elbow, shouldn't let your dog in the Elbow because of high fecal coliform count. So in other words, you know, lots of poop in the water. And the question is, well, why? Where is that coming from? And so what we do is we go and we measure we take water samples all down the river from Glenmore Dam all the way down to the confluence of the Bow, and we make measurements of the flow of the river as well. And we look at a whole bunch of water chemistry, which is not my area of expertise. I'm a geoscientist, as well as E. coli measurements and some other things to try to figure out why and where that those fecal coliforms are actually coming from. In terms of municipalities, when they are measuring water quality parameters, they're looking at things like heavy metals, a whole bunch of ions that could be deleterious to health. They could be looking for these so-called forever chemicals. They could be looking for chemicals that are in fire retardants, for firefighters, that sort of thing. So there's a whole suite of things that that municipalities are looking for, some of which are issues where, okay, we need to issue a boil water advisory right away because there are high levels of, whatever chemical it is. Whereas other things like lead, I think, are more issues, not so much like, if you drink one glass and there's some lead in it, but rather, relatively long exposure. And those are not so much like a spill of material into the river, but rather, flow over years and years and years through old pipes. And so some things are easy to fix and some are not. Some things we can fix by adding material or changing pipes. Other things, boil water advisories for short periods of time. Other things, you may have purification systems in your home, et cetera, et cetera.
And I think, oh, Michael's got one more question.
Yeah. So, Michael, I'm not sure I understand the second half of your question exactly. Do you mean like by pro for dental health? Do you mean, is fluoride added to water purely for dental reasons? Is that kind of what you mean? Yeah. So as I mentioned, I'm not a chemist. My understanding is yes, fluoride gets added to municipal water supplies in many cities, purely for purely for our teeth. I don't think there is another purpose in terms of water quality that that fluoride is added. As you probably know, because you asked the question, fluoride, we voted in Calgary, 20 years ago or something, to remove or not to add fluoride. And then that was changed recently to, we are going to be reintroducing fluoride into our water. And that's not something that can be done overnight. It's not like they just have a big bucket of fluoride and they dump one in every hour. We need to build equipment in order to do that. And that takes time and a lot of money. I will say though, that I have never had a cavity in my life until I moved to Calgary. And within 6 months, I had a cavity. I had 2 or 3, I don't know, more than I would like.
Okay, I think that puts us at time here. I can also say I've lived in Calgary my entire life, and I've always struggled with cavities. So if that says anything for you. But thank you so much, everyone, for your questions and for your engagement today. And thank you so much, Dan, for coming out and presenting, a sample of one of your lectures for prospective students and just anybody interested in UCalgary. I'm sure everyone really, really appreciates it. But I think if that's all for tonight, I think we're just going to wrap up here.
Great. Nice meeting you all. Hope to see you all in the fall. Or
Awesome.
Next fall, I guess.
Yeah, something like that.
Awesome.
Have a great night, everybody.